So this hydraulic system and components will be used in a high capacity heavy duty mining and maintenance crane, which will be used on an iron ore mine site to interchange high wear components. The hydraulic components in this system will be used to provide the lifting functions for all those applications. First, we have the prime mover, which is the electric motor and hydraulic pump set. So this item provides the input power to the system, which then distributes the power to all actuators and functions. So we have a 250 kilowatt high efficiency electric motor rigidly connected to 500cc closed loop axial piston pump and a 250cc open loop axial piston pump. So the main lifting or luffing function of the crane is performed by these two actuators, which are fed from the prime mover. These have a 300 tonne capacity each to provide the luffing motion of the crane. Back there we have the hydraulic power unit enclosed housing where the prime mover will be located, along with the hydraulic reservoir, all control valving, filtration, sensing and telemetry. Access, maintainability and serviceability was a key project requirement, which also presented a large design challenge. To make something accessible and maintainable while still fitting in a very small overall space envelope with this type of equipment is extremely challenging. So we've still managed to make all the key service items, filters, sensors, anything that requires regular maintenance or inspection to be very accessible for the operator, whilst maintaining all the other elements of making the main pump set removable, fitting in the overall space envelope. One of the major benefits of using a closed loop pump in this application, because it's a closed circuit, it brings down the requirement for the reservoir sizing, especially when we have a very tight space constraint where we can fit the HPU. Having a minimised reservoir footprint is really important. So this is the pressure unloading and pressure filtration component for the open loop system that feeds the proportional valve bank. So this has a large slip-in ATOS unloading valve combined with a high pressure filter unit, which protects the open loop system and provides the safety unloading relieving function for the open loop system. The application for this power unit is for a large industrial crane, jib crane. The main actuators on the crane are sophisticated piston motors, and each of those piston motors have a case drain which provides the passage for the internal leakage of the motor to return to tank. And given the value and complexity of those motors, each of the motor case drains is returned to the HPU and has inline case drain flow monitoring, which provides a predictive real-time measure of wear and performance of winch motors, and that way the end user can actively monitor any changes to performance in the system or predict any potential major failures on expensive hydraulic items. So this is a filling filtration system for the reservoir, so that when in service, if the fluid level in the tank needs to be adjusted, it can be done through here positively, and to reduces the risk for particle contamination because we're exposing the tank to atmosphere. So this area of the hydraulic reservoir features a suction isolation and strainer, which has an inbuilt closing valve mechanism. So we can close this valve and change the inbuilt strainer element without the risk of the tank volume displacing. It also has feedback on valve position to ensure that the control system knows not to start the pump when the valve is closed, because that provides a risk of critical damage to the very complex and expensive pump. If our suction valve is closed and we try and start, we'll create cavitation and damage to the pump. And then also we have an internal heating element in the reservoir to ensure the fluid inside the tank is at a minimum temperature for optimum operation.